Good afternoon. I hope you are not too tired at the last day of our Airflow Summit. My name is Katarzyna Kałek. I'm a lead engineer at OLX, and today I have a pleasure and honor of speaking with a principal data engineer, architect extraordinaire, and my work bestie, Jakub Orłowski. So today we will start with introducing ourselves, telling a little bit why do we feel entitled to speak here at this conference. Then we will talk a bit about our data pipelines. Then I will introduce you to a DAG Factory concept. How does it help in general? How does it help with integrating Airflow with other data tools? Then we will talk a bit about the aspects of data governance using DAG Factory. And finally, we will tell you what we are cooking when it comes to new data architecture in our company.
All right, so let me start by giving you a quick overview of our company, because some of you may not be aware of it. So let me start with here. We are building a more sustainable world through trade. Our marketplace ecosystems are enabled by tech, they are powered by trust, and they are loved by millions of customers. And by serving hundreds of millions of people every month, we help people buy and sell cars, find housing, get jobs, and exchange household goods, and much, much more. So this job on its own is already quite cool, but the most important part of it is actually that we help people get more from the world's limited resources. And we are proud to have a positive contribution to this world and to this planet. We truly believe in the power of circular economy. And honestly, with this, we aim to replace the linear, like a take, make, and dispose model with one where materials, products, and processes are designed for reuse and regeneration, continuously repurposed to minimize waste and optimize for life cycle efficiency. In a circular economy, everybody wins. It's buyers, it's sellers, and it's also the planet. So now, how do we achieve this? When it comes to our data pipelines, well, of course, we are here in the heart of our data processing. It's Airflow. Every day, we generate a massive amount of data on our platforms. From clickstream, transactions, events coming through our apps, web, and microservices, this all lands in our landing zone, in our massive data lake. Then we bring this all together, and for that, we use Airflow. It's not only a scheduling platform, it's really an orchestrator. We use it to orchestrate reliable data products on top of those massive data sets we consume. With this, we ensure that the data moves and transforms and lands exactly where it should every single time. Now, from there, these curated data products, they power everything on our products, everything from analytics and dashboards through AI-driven automation and personalized experiences for our users. In short, we turn raw data into real value using Airflow. And then here's something crazy. So we run about 70,000 high-performance tasks every day. And they span across almost 2,000 DAGs, most of them super high efficiency. And this happens on a single Airflow deployment. Now, we have seen much bigger workloads during this conference, but this is probably the most efficient usage of a single deployment out there, or at least the one we know of. And how do we achieve this? Well, instead of hand coding every single DAG, we focus on reusable logic and building on each other. We then build templates which promote modularity and reusability with minimal code duplication and easier maintenance and scalability. And all this is enabled through a DAG Factory concept, which Kasia will now walk you through.
Yes, indeed. The numbers that Jakub presented wouldn't be achievable without DAG Factory. So now is the time to tell you, if you didn't hear so far at this conference about the DAG Factory, what the DAG Factory actually is conceptually. So the idea is very simple. we define our workloads in a declarative way in the files of predefined structure, typically YAML, but it could be JSON, it could be XML, it could be CSV, whatever you really like. And then with a script, we transfer those files into DAGs. Now the rest is just a matter of implementation. Of course, you can use the open source DAG Factory library for astronomer, for instance. You can also build your own implementation. You can choose whether you would like to write the DAG files directly or maybe save them as pickles and only load those pickles later to pick up by the workers and the scheduler. And of course, you can control what content of those files should be and what should be supported. So here we have, I would say, a semi-advanced example of this kind of configuration file. The minimal setup could be really to provide the type and the schedule. Because in our case, we abstract from Airflow concepts. And this kind of file that I have presented here is something we call a step, because it represents as a single action that you want to perform, and it can be rendered later into either a single task or a group of tasks. It could be the same operator, it could be different operators. This particular case is actually running a SQL query or SQL queries to transform several data tables into statistics that we will show later to the seller on our real estate platform. So you can notice here the template block. If you attended yesterday the session conducted by Max, amazing presentation by the way, about parameterized data transformation. This is exactly what we do achieve here with templating and variables interpolation. So we not only reuse the DAG code itself, but we also reuse the SQL query. And here, this example that I just show you of the file is rendered to a task group. That is calculating exactly the same metrics, but with different granularity. We have the metrics for 1 day, 1 week, 1 month, or 1 quarter, because that's how our customers expect them to see it on the platform. And we also want to ensure that we are not running aggregations when this is presented on our platform, but rather the data is pre-calculated. And since this class grid is, all the tasks are sharing the upstream and downstream dependencies, then we can move on to loading the data into an HTTP endpoint that would also be achieved by a grid of tasks, in this case, a sequence of different operators. So when it comes to benefits of using this DAG Factory pattern, my personal favorite is the ease of upgrades and maintenance. And okay, I'm not going to lie to you. It's easy for the DAG authors, not exactly for us, the maintainers. But really, it becomes a process, the upgrade of a version. It becomes a process of upgrading the library to your software that is heavily tested, and if anything breaks, we know it immediately. I'm a software engineer myself, so this is something that is very much familiar to me. And when it comes to forcing people to migrate their stuff, it's from our experience, it's something nightmarish. If you want people to change from one tree or catalog to another, it can take 6 months. So in this particular case, with the DAG Factory, we didn't have this problem, because the DAG authors do not have to change anything in their files at all. So another benefit is running the high-quality code, no matter who is the DAG author. So you don't really have to know how to write Python code. to run data pipelines. So we can let our colleagues focus on the things that they are good at. So data engineers would build reliable data models. Data analysts can focus on the analytics. Data scientists can focus on machine learning algorithms and so on. In our data organization, we also have data practitioners who are not technical at all, and the top of their skills is using some SQL. For instance, we have teams that are cooperating with law enforcement by extracting data to fight the fraudsters. So also this kind of personas can be found in DAGs in a declarative way. Seriously, the only skills you can do is to write a long file, which I guess any Muppet could do. And finally, we have the possibility of automating and intercepting the tasks that we are orchestrating and integrating everything that runs on our Airflow platform with different components of our data platform. So let me illustrate it with some examples. Open Metadata is currently probably a #1 open source data discovery platform. It combines the capabilities of data lineage, quality, documentation, managing business definition of the metrics, recently also data contracts. It grows insanely fast, and it has a team of really engaged team of maintainers. So those releases are frequent, and it's also a very good place to start with open source contributions. Fun fact, if you use the official Helm chart from Open Metadata to deploy it, you'll also end up with your Airflow instance running under the hood to execute the ingestion tasks and the data quality tasks. But when it comes to extracting data from Airflow, the integration here is a little bit rough because it requires the DAG auto to predefine inlets and outlets on each operator to indicate what data is it using and what data is it producing. So you need to rely on the data auto to care about it and to actually remember about it. But what if we had a way to actually extract this metadata automatically? For instance, if we are running a SQL query, we could pass this query, calculate inlets and outlets, and automatically send it to open metadata on every task execution. Then we would end up with this beautiful lineage, knowing who's using our data and how, learning how the tables that we would like to use are built, so it increases our trust in the data, and with zero effort from the person who is actually writing the pipeline. Another example is Monte Carlo. Monte Carlo is a robust data observability platform, which allows setting up monitors and alerts on data assets and assessing their health in a holistic way, including anomaly detection. It integrates with Airflow via callbacks and SQL commands that are linking the DAGs and tasks with the data assets and queries. So again, here's another example of how how DAG Factory concept helps us with this integration, because we can intercept every SQL query that is running on our Airflow instance and add necessary comment as a SQL prefix. Also, we can easily include, again, the callback that will communicate with Monte Carlo and every task execution. And since I talked a bit about nice additions that we have, I will also tell you a bit about the restrictions that we introduced with DAG Factory. So, Jakub, I think our team became a bottleneck.
Decentralize.
But it's hard to coordinate.
Well, then centralize.
But it doesn't scale.
Decentralize just a little.
Okay. So our idea how to decentralize this centralized approach just a little is introducing the concept of the namespaces. So a namespace would be an abstraction over a team, a project, sometimes the environment, typically represented by a single Git repository, but it could be just as well a branch or a directory even, depending on your needs. So this kind of namespace defines the DAG ownership and configuration like destination for the Slack alerts and so on. But also, most importantly, it gives the owner a piece of infrastructure on their own. So here, you have the operators you can use, you have the connections you can use. We can even define how much Kubernetes resources you can use on your Spike jobs. We can define secrets management or IMRs that certain namespace could use. And of course, DAG Factory, apart from this, will take care of the naming convention, tagging, and other things that will make our DAGs easily discoverable. Okay, but how do we take care of enforcing these restrictions? And here's the part that is a little controversial, but we only use our own operators. And sure, some people hate us for it because they would like some more flexibility, but at the same time, we can inject the namespace information to the operator and only use those resources that are actually attached to the namespace. And we are using this DAG Factory concept and implementation successfully since, I think, 2019 to manage and support our two-tier architecture consisting of data lake and data warehouse. And our DAGs are neatly organized. It was never a problem. But the architecture itself has many other challenges. And interestingly enough, right now that we are shaping the future of the architecture, DAG Factory is helping us with this even more.
Indeed. When it comes to changes that we are now introducing to our data platform and our tech stack, we have our platform neatly organized around the capabilities and I guess on the very bottom of it, in the foundational technology, technology that really enables our stack to deliver reliable data is obviously Airflow. And with Airflow and Airbyte, for increasing amount of ingestion jobs we have the reusability of work, and we are introducing more and more of those ingestion mechanisms as we go. For the governance, we have some systems, but I guess the one that is really worth mentioning, we are on AWS. We are using a lake formation for data governance and for making sure that only, everybody has access to the data they should, but only those that they're allowed to see. Now, for processing, we have a winning combination here of Spark and Trino. Those jobs are orchestrated from Airflow, and that's just yet another example of that parametric pipelines that Max was mentioning yesterday. So we have the dynamically generated transformations, and a lot of code is being reused. Also specifying execution parameters, especially on Spark, is simplified, and many people simply do that, and they don't have to be expert in Spark in order to run Spark workload. They can simply focus on the actual transformation that they would like to achieve with Spark, and we take care of the rest. Now, when it comes to data quality, it's by default and by design, and from two different sites. Kasia already mentioned about Monte Carlo for observability. Now, we also have growth expectations, and we treat them as kind of unit test suite for data transformation. And also we have increasing amount of those tests being executed straight from Airflow. For storage, and we've been in a few discussions already during this summit here, we are turning towards Iceberg. And for those of you who are, especially on Amazon, on AWS, it's an experience. Well, it's an exercise we're doing. I think it simplifies access with Spark and with Trino and Athena. We can also natively access those tables with from Redshift using spectrum. So far we couldn't be happier with Iceberg. And by the way, we are also using the latest from Amazon, so the S3 tables for managed Iceberg. When it comes to consumption, well, for us, Superset was an obvious choice since we want to stay close to the Airflow family and works like a charm. Now, we top it off with yet another Airflow-powered solution, which is Open Metadata, indeed, for the lineage and data catalog. Now, I guess the biggest learning from last few years is the importance of schema-first approach for table creation. So after years and years of indeed not really taking too much effort in making sure that the tables are created with a central tool, we swamped our lake, and this was not really a beautiful place to gain the value out of. With the schema-first approach and with taking care of schema or table creation with the DD operator, we make sure that we have data quality assurance. We early validate that only compliant data enters downstream systems. And since we are moving towards data products, this is really important. We have predictable data contracts, so we integrate easy between producers and consumers. We have safe transformations because we rely on known types and structures. And finally, with the governance and lineage, this is simply a match made in heaven. And a typical neuron of transformation for our data products looks like this. So we have the raw data transformation that is first being checked for freshness, then being transformed and assured for quality, only to trigger through asset event next data products that would benefit from data in that data set. Now, we achieve efficiency by going from raw data to insights, but one step at a time. On every single layer here, we make sure that we improve and at the same time check for quality and reusability every single transformation. So by that, again, we are simply building on each other and through that gain more value than we could.
Thank you.